Right, so question 9 from today's 2022 paper 2 Leaving Cert math paper. So a bit of geometry and a bit of trigonometry in here by the looks of it. So Oscar, what are you up to, Oscar? He's taking some measurements and is using trigonometry. Okay, so that's kind of giving you a hint that you need to use trigonometry first. Okay, Oscar takes measurements of two adjacent triangular fields. Field 1, field 2, B lines on the line, and they're helpfully pointing out, oh yeah, where's the 50 degrees? So you're given one angle and shed load of distances. And they're helpfully pointing out that ABC is not a right angle triangle. They didn't do it in 2020, and the triangle looked a hell of a lot like a right angle triangle. I'm sure people fell into that trap, and the SEC probably got a bit of a bollocking at the markers conference as a result, and they're making sure they don't fall into that trap again, because that does look quite a little bit perpendicular, so they're fair play to them for pointing that out anyway. So find the area of field 1 and hence the area of field 2. So it looks like, well, okay, into the formula tables, and where's the areas? Trusty areas, and I'd say we're looking at this one. So for an area of triangle, so area is equal to half AB sine C. Alright, so let's see if that works for that one. So that would be the half AB sine C, so let's see, half of 35 by 30 by sine of 50. Okay, so excuse me, 15 by 35 by sine 50 is the area there. Gonna have to go into the calculator. Normally I like to do it in my head, but I'm not good at getting sine 50 in my head. So I'm gonna have to use this lad. Okay, multiply by 15 and 35. By 15. It's 15, not 14. 15 multiplied by 35 equals, so 402. A is 402.17. Now again, this is something that is a bit of a bugbear. You just have to be careful of how many decimal places. Significant figures in the question are about 2 and I would say, yeah, probably 1 decimal place. Now, and also units, so let's be just careful about units. So it's meters squared. So I would say area probably is 402, we'll probably get away with 402.2 meters squared. I'm going to call that. All right, and hence the area of field 2. I mean, not sure how that is hence, but look, I would say the same formula can be used, except this time it's that side and the full side. So it's 35, and then the other number is just adding on 10 to that. So really it's the same number. It's a half A, and then this time it's just B plus 10 sine C. So basically it's the same thing. So it's 35 over 2 by this time 40 sine 50. So is there any way I can do that without okay, that was originally 30, and I'm now going to, so I suppose if I divide that by 30 and multiply it by 40, would that work? It should. Yeah, so the new area of field. Oh yeah, okay. We're trying to get the total. So the area of the total now is equal to, let's just do 402 by, okay. So I'm going to divide by the old one, which is 30. So it's 4 over 3. So 402 by 403. 402 by 4 divided by 3. 536. That's nice and even. 536 meters squared. Would that make sense? It probably would, yeah. So field 2 is equal to 536 minus 402, which is equal to 134 meters squared. So hopefully that's okay. Area field 2. Alright, so that's okay so far. Right. Length of the perimeter of field 1. And okay, then we're on to airplanes. So the perimeter of field 1. Okay, so that looks okay because we have this side, we have that side, and we just need that side. I'm smelling a cosine rule here probably. So let's go for the cosine rule. And where is that? Yeah, it's probably a cosine rule, all right, for that one. So let's go for it. Yeah, here we are. Okay, so a squared is equal to b squared plus c squared minus 2bc cos A. So just have to be careful that everything is transposed into what this is now. So the angle A, yeah, okay, so it is the angle A, so that's fine. We can work with those. So yeah, so, and we're trying to get the opposite of angle A, which is great. So we can keep that over that side. So we are looking for A, so that's handy, that's over there. So it's the 35 squared plus 30 squared minus 2bc. So it's those multiplied together, so it's 70 by 30 cos A. So cos 50, yeah. Okay, so what's cos 50? Awkward enough. I like the 45s and 60s and stuff. Cos 50 is 0.643. Multiply that by what is it? 21. So multiply that by 70 by 30. We get that. 1349.9. Okay, 35 squared. 12225. 30 squared is, what's that, 900? Okay, so on all of that should be equal to this lad. Okay, so 2125 minus 1350. Fuck it, I'm just gonna round it, 1350. So we get 7, 7. So 775 looks suspiciously like a square number. Hoping it is. What would that be? What square number would that be? Anyway, enough for the guessing. Okay, I know I should have to guess, shouldn't I? Okay, 10 tens is 100. 20 by 20 is 400. 30 by 30. Fuck it. Okay, 20. Okay, so it's not a square number. It's A is 27.5. Okay, and I suppose strictly speaking, if we're to follow the significant figures in the question, it's 2 significant figures in the question, probably 2 significant figures in the answer. So 27.5 is more than enough detail, but maybe you could call it 28 meters as well. Oh, correct to the nearest meter squared is the area. Yeah. So you're now asked you're now asked the perimeter. Okay, so the perimeter then is, that sounds all right. You know, a sanity check, 27 meters looks okay there. So the perimeter then, nice easy formula for that just is the sum of all sides. 35 plus 30 plus our little 27.5. So it is, let's call it 28, okay? So it's 65 plus 28. So the perimeter is now going to be equal to 93 meters. And important to have the units there of that. So that is fairly okay. That was, I mean, application of the cosine rule and so on. And it should be all right. Now we have an airplane. Now we're going to go on an airplane. Okay, let's see. So, doesn't take into account of the Doppler effect, happily. So it's just pure listening to sounds on the ground. Okay, so it's flying at a constant height of 10 kilometers above the ground. And so the sound is traveling in a different direction. Sound is going to travel across the hypotenuse there. So the sound is going to travel this way, the airplane is going to travel this way, and we're talking about a little bit of differential between the two. So use diagram 1 to show that it takes 41 seconds. So let's have a look at that. All right. Okay, so as the airplane flies, takes a sound, use the information to take 41 seconds. So the sound to reach Oscar. So, okay, so I suppose basic trig, or just triangles really. So we have 10 kilometers there. That's 45. Suppose the 45, then that has to be 10 as well, because the 45-degree angle triangle is 1 root 2. So that's 10, and that's 10 root 2. All right. Now these show questions are great because it's you know the answer and you're just guiding yourself in the right direction towards it. So they're always nice ones to do. Okay, so the speed is equal to distance over time. So what is the time is equal to distance over speed. So the time taken for the sound to reach Oscar, it's Oscar again. Oh, what is Oscar up to? He's up into everything. Okay, so time is equal to 10 root 2 over the speed of sound, 343. Now let's make sure the units are right. So it's meters per second, and we're using kilometers up there. So we have to put that into kilometers per second. So that is that. Okay, so that will be about 30 root 2 then. 30 root 2 is about 1.4, so it'll be a 30 and a bit, so that sounds like it's 41 seconds, so we're probably on the right track. So let's throw it into the old calculator. Okay, root 2 multiplied by 10, so to give us 14, and then divided by 0.3, 43 equals 41 seconds. Okay, so t is equal to 41 seconds. Great. All right, lovely. Airplane flying at a constant speed of 255 meters per second. So it's below Mach 1 anyway. It's not going to break the sound barrier there at that level. By the time Oscar hears the sound, the plane is trying to work out the size of the angle. So by the time Oscar hears the sound, so in other words, what that's saying is, and this is just something you have to think about, and this is probably where the question might pose difficulty to people. So by the time hears the sound means that the length of time that takes is the same as the length of time that takes. So now we can say how much distance did it travel in that time. So how much distance did it travel time in that 41 seconds? So we said that it's traveling at, what speed is the plane going? 255 meters per second. V is equal to 255 meters per second. We just have to be a little bit careful of that. So what distance does it travel in that time? Well, actually we don't have to worry about the seconds because it's in meters per second. So it's 255 by 41. Okay, so what distance will that be? Probably be a little nibble bit bigger than 10, and then we can take that away. So 255 by 41. So it's 10,455. 10,455. So that's, we just have to be careful with the units. That's going to be meters, or we could say that that's kilometers now. Now, right, so up here, the fiddly bit there is going to be that total minus 10. So it's traveled that full distance. So what's that distance there? So distance x is now going to be equal to 10, that minus 10. So it's 455 meters is distance x. We're told that this is 10 kilometers. So the angle theta, where's that angle? So the angle theta there is going to be tan of the angle theta is going to be opposite, which is 455. Well, it's put in kilometers, 0.455, because that is going to be in kilometers 10. So that's quite a small tan. That's going to be a little mini tan. So a tan. So 0.0455. How do I, now the most difficult thing in the world is going to be how I arctan that. Oh, I'm going to plug it into Google, because that is probably the safest way of doing it. So arctan of Google is great for, yeah, so 0.0455. Hope it knows it's in degrees now. And is it going to give it to me at all? Normally it gives it to me, but anyway, okay, so yeah. Anyway, look, it's a small angle. I mean, that's just detail, as people would say. The getting the final step. I'll find that in a while. Okay, so now, P3. So basically, the answer is arctan. So theta is equal to arctan 0.0455, and I'll find that in a bit. Okay. So P1 and P2. Okay, briefly explain why the following equation holds. Well, that's pretty important to explain it. Don't lose any marks here. So, okay, so time for the sound to travel is equal to the time for the plane to travel. That distance that it travels. So T sound is equal to the distance travelled by the sound over the velocity of the sound. And that is equal to the distance travelled by the plane over the velocity of the plane. So the distance of the plane is these two d's over the velocity of the plane. We're told that that's 255. So it's 2d over, now it's 0.255 because we're going to put it in kilometers per second. And the distance of the sound, well, the velocity of the sound we have is 0.343, and the distance of the sound, so let's just do that separately. Distance of the sound travels is going to be this distance here, x. Let's call it distance of sound. So distance of the sound is equal to the, by Pythagoras, it's going to be the square root of the square of that and the square of that. So it's d squared plus 10 squared, which is 100. So I think that proves that one. Solve the equation to find the value of d. Okay, and then we're finished that one, which is pretty good. Okay, solve the equation to find the value of d. Okay, so we have to solve which equation? The one up there, yeah. Okay, so that should be fairly straightforward. So it's d squared plus 100 root equals 2d. So that's 0.343 over 0.255. Probably have to square both sides then to get d squared plus 100 is equal to, so we get 4d squared by 0.3, that factor there, 0.255 all squared. Right, so let's see what that number is. I'm hoping it kind of comes out nice and tidy, but maybe it doesn't, and it doesn't matter if it doesn't. But 0.3, what am I doing? Okay. I don't know how to use a calculator. I haven't used a calculator in years. So how do I do this? 0.3. You shouldn't need calculators. Shouldn't need these bloody newfangled calculators that are destroying maths. Divided by 0.255 should be all in your heads. That's the way it should be done. So that factor is that. We're going to square that. And we get this. We're going to multiply it by 4. And we get this. Lots of decimal places there, but I'm going to leave out a lot of them. So it's equal to 7.245 d squared on that side. D squared plus 100 is equal to that. So what does it give me? It gives, okay, so 6.24 d squared equals 100. So d squared is equal to, okay, so it's 100 divided by 6.24, and then square root that. So 0.4. Okay, so d being 0.4, and would that make sense? Let's see. So that would be 0.4 kilometers. Okay, let's see, would that make sense? Yeah, seems okay. All right, so 0.4 kilometers. Right, so that is that one, and that is, not sure if I got the actual numbers right there, but that's the general method. And I think if you follow that, really the only equation behind the scenes there is just velocity is equal to distance over time, and follow that rigorously and you'll get the method. And always be aware that even if you get the number answer wrong, then as long as you got the core method right, then you're on safe ground.